I'm Poonam Agarwal from NXP Semiconductors. So I've been working with Linux systems for NXP Layerscape platforms. And my today's presentation is on how we can improve Linux testing or the predictability of the open source Linux code. So what we have come up, myself and my colleague, we have tried to put a small tool which is based on artificial intelligence, which can kind of do prediction of the Linux health or the software health, so that we can really identify what are the focus areas for more testing, which requires more testing. So those are kind of the problems which we are trying to solve with this tool. So I'll just go over this. So we are new to AI, so we try to use a very basic method of application artificial intelligence here, and next step would be to make it more refined. So a top level agenda is I'll be sharing with you the tool overview. So how does the tool look like in terms of the block diagram? Tool usability, like in which use cases the tool would be useful and who are the people who can use this tool. What are the sample questions which the tool can answer? And the next steps, what should be in this area. Potential use cases, again, like I've also covered a Linux safety use case here. I'm not sure I'll get the time to cover that, but I've tried to explain how this tool can be used for Linux certification as well, because there's one initiative which is going on in Linux Foundation, which is ELISA. So just trying to think on that direction as well. Okay, so, and this tool, this code of this tool is Python based, and it is there on GitHub. So I'll also invite you guys to look at it and we can collaborate. Okay, so this is Intelligent Linux Test Suite, and the first box to the left is kind of the questions which the tool has the capability to answer, like a question like, is upstream status? So if it's upstream Linux repo, is it okay to cut a distro out of that? So various distro vendors, whenever they cut out a distro from a vanilla kernel, so what are the things they should look at and how this tool can help them? So if they can ask this kind of question, that the tool provides them, like this subsystem is showing more failures, or this IPs or these platforms do not have good pass health or the past results. So the distro communities can decide, like, are these things which are blocking their distro distribution, should they wait for a bug fix, or should they fix them, or should they go ahead? Next is like, this is basically from NXP perspective. So why NXP wanted this kind of tool, and it is being used in NXP for Layerscape SDKs. So for example, whenever a device SoC vendor like NXP wants to create a release branch for Linux to add a new platform support. So for example, it could be a LX2160 SoC which has to be added into the Linux. So which is the good code base which should be taken as a base? Definitely the Layerscape SDK code base would be more healthy in terms of the support which it has for the NXP devices. But there could be cases like the upstream code is better in terms of like some drivers are already there in upstream which are not available in LSDK, or the bug fixes are there in upstream. So this is again a good opportunity for the NXP LSDK team to decide which should be the good base code when they decide to add a new platform to the Linux. This could be an answer, this could be the third question, like, should I use LSDK or upstream for my software product? So like if I talk about NXP again, and one of the customer of NXP could be Cisco, and they might want to cut out a product out of for a Layerscape platform of NXP. So they usually come to us with questions like, should we use the upstream code base, or should we use the LSDK? So because there could be scenarios that various patches that are there in Layerscape SDK code base are not upstream yet. So generally we are supposed to give answers to them like, this is the test report, and these patches are not there, or these IPs are not there. So you might have to backport them if you use upstream. So this is again a tool which will give a quick indication of which IPs are failing in upstream and which are not failing in upstream. So this can be again a good decision point which can be taken by the customer and the partners. Lastly, it also will list the best rebase sanity test suite. So whenever a internal branch would like to rebase with the latest upstream code, so whenever a rebase happens, it is important that that rebase is tested well, so that the base code is still in a good shape. So what this tool can help to do is, it will identify the failing test cases, like these are the areas which will fail. So it will predict that kind of report, and those failing test cases should be ideally the must test cases which should be run whenever a rebase is attempted. So the tool looks like this, which is towards the center, which has got the amber block, which is doing the model training. So it's a AI based tool written in Python, and it uses the decision tree classification algorithm to train itself. So first block is model training and accuracy check, so where the model gets trained with the input data and it checks its accuracy. So this tool right now is showing a 97% accuracy. The data which is provided to it is NXP test reports. So it's the test reports which are run by the NXP regression, Linux regression teams. So I'll just share with you that input also. So this amber box gets inputs from that Excel, which is the bullet number 3 there. And this spreadsheet is actually a list of test reports which are generated from NXP kernel CI. So NXP is continuously regressing the upstream Linux and doing a list of testing, maybe weekly or daily. So those regressions are captured in terms of the test reports. So there are a set of test cases, and those are run always based on the latest upstream head, the kernel.org. The second test reports are NXP LSDK. So whenever the LSDK gets released, so all those test cases are again run against the LSDK code base, so which is vanilla kernel plus lot of NXP patches. So both these test reports are fed to the model, and the model gets trained based on that. And now the user, after the model gets trained, the user can ask these type of questions. Like it can ask the model to predict pass or failure for a test case. So for example, I have a particular USB test case. So what I can ask the model is, will this test case pass or fail for a particular platform? And the question would be on upstream or the LSDK. So what the model does is, it actually takes as input the test reports it has already taken. It has got trained based on the inputs, and now it will it computes, like actually it understands the history of various instances when this test case was passed, when this test case got failed, and now it has got a fairly good idea of now what is the situation today, what is the situation, is has it got more chances of failure, or it is a good candidate to be passed always. So for example, if I consider a PowerPC subsystem, so a PowerPC I would say is kind of mature now. So we are that subsystem will be showing less bugs. But if I talk about some other subsystem, it could be a FlexPy controller, for example, which is coming from NXP and which has only seen 2 to 3 silicons till now. So that area is supposed to be growing still, and that area will definitely show bugs, like sometimes it will break, sometimes it will work. So those areas can be identified with this tool. So the second question is predict the past failed test cases for a platform. So for example, an NXP LX2160 platform, if I want to check the status of how this platform will fare in the upstream or LSDK code base, so it will give me the list of failed test cases which are bound to fail, and those I should look at, and we need to do more regression on that. Similarly, it is for a IP like USB, QSPI. The fourth question is the IP subsystem stability. So it is not a vendor specific IP, here it is the complete subsystem. So it could be a storage subsystem, it could be a SATA subsystem, it could be a process subsystem. So it all depends on what kind of test cases are being fed to the tool, and based on that, this model should be able to give us the list of test cases which will fail, which are predicted to be getting failed. So on next steps, like one is the UI portion, which we want to implement, like it can be a natural language processing kind of interface which the user can get, so that right now the questions are very much hard coded. So the user can can ask the question in any language, and the answer should be given by the machine based on after processing that natural language. And second thing what we can do is that instead of using this only for NXP kernel CI or NXP LSTK, we can get the test reports from the open source initiatives like the kernel CI or the LKFT, and the Jira as well, because the Jira also has got a lot of bug reports. So this is kind of because we need a lot of good database of test reports, so that the tool can predict very accurately. So as I explained before, the model usability is predicting the outcome of a test case based on existing inputs. So it is like there are various instances of the test case in the test report, and and the test results as well, whether it is pass or fail. So based on that, the model can predict the outcome of any test case or of any subsystem, whether that test case has got chances of failure or it has got chances of a high pass. So the typical questions could be that, is the upstream status okay to come out with a distro? Does LX2160 qualify for a SUSE distro? So it is a platform specific question, like if this SoC has got a good maintainability status in upstream. Should I use LSDK or upstream for my software product? So these are again the same questions which I mentioned earlier. And again, the rebase decision, if I want to rebase my code, my product to a newer upstream version, so is this a good point to rebase? So I'll just move to the other slide. So this is a specific question where does the LX2160 qualify for SUSE distro? So this was a specific question which NXP, what as an architect or what as a human intelligence, what we do is like we know LX2160 and we will scan all the test reports of all the test data, and then we'll figure out like USB is failing or QSPI is failing or SATA is failing. So for this, if this tool is used, we just have to use the second option, predict the pass-fail test cases for a platform, and the input would be upstream. And the second question is, can I define an optimized regression test suite to sanitize LX2160 for SUSE? So this is basically the list of test cases which the tool has predicted to fail definitely, and then these are the test cases which should be always run or which are must run, so that you know really that this is the area which has to be validated properly. Which IPs need to be ported from LSDK? So there could be certain areas which are showing complete failures because the patches are not there in upstream. So those areas can be easily identified, and those patches have to be ported from Layerscape SDK to upstream. So these are kind of the decisions which can be made when using this tool. This is a second example of how to use this tool. This is again an NXP specific example. If I have a new platform LS28A, 1028A, and I need to get the answer for where I should, which should be the base code for which I should select before adding this platform. So I know on, for example, in LS1028A to the right side, that it has got a Cortex A72. It has got a FlexSpy interface, it has got I2C, GPIO, and I also know like these IPs are coming from the similar SoCs which are to the right. So based on this, if I provide the questions to the tool like, is FlexSpy, what is the status of FlexSpy on LX2160, and if the tool gives me a positive answer, in that case FlexSpy should be picked from the upstream code base. So these are again the kind of decisions which can be made before picking a base code to add a new platform. So these are some of the next steps which are required, which we have identified, which have to be done in this tool. One is to add the time sensitiveness to this database. So right now what it is doing is it does not understand basically it does not understand that this was tested earlier, now this has been tested later. So there is no time stamping understanding to the machine. So that is why it doesn't know that things were failing earlier, but now they have started to get passed. So that means the system things have been matured and they are expected to be matured now. And another case could be like one of the subsystem is continuously flaky, like it's sometimes passes, sometimes fails. So it's constantly it is showing a flakiness. So these two cases, if the tool should be able to understand that the past has to have a less weightage, the past inputs have to have a less weightage, and the recent inputs have to have a more weightage. So we have to figure out how to tell to the tool this, that you need to add weights based on the timestamps of the test cases. The second thing is that add test results from other SOC vendors. So right now this test report and the complete is only regarding the NXP SOCs, but if our test report adds the support, the test results for other vendors like the Intel SOCs and the Marvel SOCs, in that case it will give us a better picture of subsystem stability, like USB. So in that case it would be like all the USB vendors would be having their test cases there, and then it would give me a better stability, like USB subsystem is more stable there. And it can be used for other vendors as well. The third thing is like what the model has predicted versus what is the actual result. So what we want to do is that if the model has predicted that this particular test case is going to get failed, so we want to check that how accurately it has predicted this. So if we, one thing is like by human intelligence, I check like, yes, it is a reused IP, it is very stable in upstream and it should pass. And second thing is that I test myself and see how accurately the model has predicted. So this is one more thing which we thought we should do so that we have a more deterministic outcome of the model. So this is just an example of how this tool can be used. And a specific example has been taken for Linux safety with the open source software. Now the typical life cycle of any product development would be a kernel.org release which has been forked into an internal tree, and then some new development happens in terms of the platform support and the drivers get added, and then they become a part of kernel.org. And a release would get cut from this branch itself before it gets submitted to the ORG. Now the tool which is the yellow box here, this is the time when we can use this tool and predict like how good is kernel.org and which areas are, which are the problem areas there, which are the critical bugs which should be fixed. So how do we do this is that to the right side it says that predicts the optimized test cases, and the test data which this model should use to get trained is safety certification test cases. If we are talking about Linux safety, so we are expecting that we would have a list of test cases which are required for Linux to qualify a safety criteria. So those test cases would be a key requirement for me to evaluate if the kernel.org is in good shape, from where I can take out a fork and do my development for Linux safety product. If I see some critical failures there on the Linux safety test cases, for example, those would be the things I would address first before I go ahead with my development. This is another view of the same example where we, it is again Linux safety certification. Towards the top is the upstream Linux. We do a rebase, we run this tool, we take out the list of test cases which are bound to fail or which have been predicted to be failing, and then we take a decision of fixing those issues, or we go ahead because they are probably less critical issues, and then the team can do the internal developments. In between there would be a rebase cycle again. There could be some rebase cycles where again this tool could be used, and then the product can go to final certification to the end. So what we are not saying that we will only run those test cases which the tool predicts that they are failing. The test cases which will be finally run to get the product certified would be all the test cases. But definitely this tool is giving a good indication of which are the failure areas and which should be tested well, so that my internal development can happen smoothly. I should not get blocked with the critical failures at the starting point itself. Yeah, so these are just other use cases which we have already talked, but it's like collaborating with kernel CI, LKFT for having more test cases. So right now the coverage is very less. So we would like to add coverage for more subsystems and more devices, more drivers, more platforms. Helping organizations in taking rebase related decisions. So we would like to roll this out and see how the organization can use it. Helping the distro vendors in choosing the correct LTS versions. Publishing the Linux safety scores and certifications. So at subsystem level, if this can be used to like publish that the USB subsystem has got this much score and the storage subsystem has got this much score, so that it is very useful. It could be very useful for the maintainers as well to see what are the focus areas which need more focus, with the areas which are more mature. So those kind of use cases. Yeah. So I think this is the complete presentation. So this is the code here and on GitHub. Any questions? Yes.
I don't think I understand what's the reason of using artificial intelligence in this case. Could you explain on what are the inputs to the model? So do you have input, like do you check the code which is going there, or like why? Because this sounds like a fairly simple question to answer, like test the platform and then you get the results. So why would you use the artificial intelligence to predict what the results would be if testing is that simple?
Okay, so so one thing is like I have the complete test report and I just search like these are the results. So that requires a complete testing for me. I need to do a complete testing of the test cases and I exactly point out these are the failures. Right, and what this tool, why we are proposing is that you need not do complete testing, because a lot of testing is already happening from various sources. And what this tool is doing, it is kind of taking the history along with it. It's not giving me a snapshot, it is giving me a history. So history means that this subsystem is flaky. It's like it sometimes passes, it sometimes fails. So I need this subsystem to be tested thoroughly, right? Because it's like test cases are infinite. I mean, if I want to use Linux for my use case, I can, what kind of test cases I will run? So I have my own test cases and kernel CI would be having their own test cases. So it is not easy for me to rely on some particular test report, which I might miss some test cases there. So I would like to understand the subsystem stability from the history. Like this thing never breaks or this thing keeps on breaking.
Okay.
So what this tool is doing, it is actually capturing all the instances of failures and tests and passes. So it is, whenever the test case gets run, entry gets created with a test case number, the IP, platform and the results. So whenever the test case is getting run, the test report keeps on getting increased. So it's continuous regression which is happening. So what this tool does, it sees that, okay, 10 times it passes, for example, and 3 times it fails. So it's kind of, this subsystem is weak here. It keeps on failing or it keeps on passing. So that kind of statistical analysis the model is expected to do there.
Okay, I still don't see the reason for doing artificial intelligence here. Someone introduces a bug in the code. If you don't analyze the code beforehand, before running the test case, you will still fail. And maybe the tool will not point to this test case, run this test case, and it's still failing because someone introduced the code that you're not aware of.
Yeah, right.
So I really don't understand how this tool is able to help in any case. In my opinion, it just introduces more noise rather than help selecting the test cases for.
I think the intent here is to identify hotspots in the kernel, whether it's an internal kernel or an upstream kernel, that might warrant further testing or further investigation to make sure. You mentioned something about the safety test, where if you're targeting that kernel toward a certain purpose, you want to rely on that history to qualify that your choice that you're making for this particular version is stable enough. Now, AI might be plus or minus, I'm not quite sure, I'm no subject matter expert on this, but I think that's what I understand from your presentation is what you're trying to do ultimately, just basically qualify your decision making moving forward in the development cycle of your kernel. I'm with Milosh. I mean, I don't quite understand with the AI, but maybe when you start pulling data from different test frameworks that may look at things a little bit differently, or their test cases are slightly different. I mean, it's very possible that NXP has its own, I don't know, USB subsystem tests, and upstream has their own USB subsystem tests, and you want to have some kind of an alignment there. Maybe that's where I helped. I'm not quite sure. So statistically, I don't think you need AI to get those end results if you're just using the same test suite again and again and again. But if you're starting pulling results from different places, maybe you want to use something a bit more fuzzy to align those test results. I don't know. Maybe that's what the AI, that's your intent.
Yeah. I mean, yes, you're right. The test cases, if they're coming from various sources, the test reports, so that will make it really AI. But here, the problem actually is trying to get solved specifically here is like whenever a rebase happens, so a lot of patches have come from the last rebase up to now, and how do a maintainer ensure that how much testing he should do so that he can decide that platform, that code as a good solid platform to go ahead with the release. So, for example, a kexec type of feature, kexec, which has got nothing to do with probably an XP platform. So, is that so? If there's because the tool is continuously running on weekly regression, it's doing on this code base. So it can identify that this is a problem area. So I just don't want the snapshot of. One thing is that I test everything after rebase. I test everything.
Okay, so but what's the limitation in your testing that you don't want to run all of it?
It's time.
Okay, but
it could
like
be like
time,
I'm running some tests.
Time is I don't know.
Don't say it's infinite.
Sorry?
Don't say it's infinite.
It's relative, I would say. You can always throw like more resources into it and then reduce the time, right?
I would say like definitely it's not possible always to throw all the resources in time, but I would also say that it is time, and what is the thing which needs more testing. For example, if the tool has predicted that this area is a problem area, or it has shown a lot of failures, or that means I would like to test it more thoroughly. And I mean, I would like to have a test suite which is intelligent enough, like which tells me like this has to be tested more, and this I can do with just one sanity testing kind of thing.
Yeah, but you still can look at the results, and you don't really need any artificial intelligence to do it. So you just list your areas, and okay, I mean, yeah, this is red, this is green, and that's all. That's it.
I mean,
and then you just introduce a threshold. Okay, above this threshold it's okay, below the threshold it's not okay, and you don't need any artificial intelligence.
No, I would not say like that. Actually, it's very different. It's kind of hairline between it's a pure Excel search, or it is some intelligence which is the system is drawing. But
because what you're trying to do, at least my opinion, is that you're trying to get a tank to shoot to a fly. Sorry.
Okay.
To call the question.
Squad is also like a AI for us. So.
Sorry?
Squad is like our squad is like
it's not AI.
It's not AI, but we know like what is failing. It's been failing the test case history and the known issues.
Yeah, but
so that will make myself easy to like what was
there is no artificial intelligence network in between that does something that you not even aware of. So there is no
we have
model,
clear
there is
data.
no training, there is
No,
just like a pure hard-coded precision.
Thank you.